Sketch the following convex sets and write down any vertices they have. And there's 5 there to sketch. Well, it says to sketch, which means I need to draw a picture, but not necessarily an accurate one. It just has to have all the important features. And I'm going to need room to draw that picture, so I'll do each of them on a separate page. So let me start with part A, which is the set of xy in R2 such that x plus y is less than or equal to 3, y plus 2x is greater than or equal to 2, and y is greater than or equal to 0. Well, how would I draw this set? First, I decide what it means. This means it's a set of points in R2, which is in the plane. So I would draw an x and y axes. There's my y-axis. There's my x-axis. And my region would be a set of points on that plane somewhere. Now the coordinates of my points have to satisfy all of these 3 rules at the same time. So what I can do is I can find all the sets of points that satisfy each rule separately, and the places where they overlap must be my set in the end. So let me do each of them one at a time. So first, let's do this one. X plus y is less than or equal to 3. Well, if that was an equal sign instead, I'd know what to do because it would be a line. X plus y is equal to 3 would be a line. And all I need to draw a line is to find 2 points on it and join them up. And the easiest 2 points to find would be the x-intercept and the y-intercept, because all I need to do to find them is sub in 0 for x and y separately. So let's see. If y is equal to 0, that would mean x is equal to 3, so the x-intercept is 3. Just there. Let me put the y back. And if x is equal to 0, that would mean y was equal to 3. So I can put a 3 there. It looks like my x needs a bit of help. That's better. So my line would join up those 2 points. So it goes something like this. That's the line. X plus y is equal to 3. Well, that's good. What I need to do now is decide which side of that line is x plus y is less than or equal to 3, and which side of the line is x plus y is greater than or equal to 3, so I know which one I need. And every point on one side will satisfy the inequality, and every point on the other won't. So if all I need to do is pick a point and see whether it works. Perfectly good point is, of course, the origin. Just there. And the origin is 0, 0. So if I put 0, 0 into my formula, that would give me 0 plus 0 is less than or equal to 3, which is true. So therefore the origin is part of my set, so therefore this bottom half of the line, that's my place where x plus y is less than or equal to 3. So I want this bit here. Now, I know that when I get to doing the next bit, it's going to get confusing if I've coloured in a lot of bits that I do want. So it's actually easier to cross out the bit I don't want. So instead of colouring in the bit I do want, I'm going to cross out the bit I don't want. So let me cross out this bit. Don't want that bit. So let's move on to the next inequality. Y plus 2x is greater than or equal to 2. So again, let me do exactly what I did last time and think of this as a line with an equal sign instead of a greater than or equal to. Y plus 2x is equal to 2. Alright, let's find the y and x intercepts again. If y is equal to 0, I get 2x is equal to 2, which means that x is equal to 1, so that's here. And put the y back. If x is equal to 0, I get y is equal to 2, so that's here. And I want to join up those 2 points. So something like that. Now all I need to do is figure out which side of that line I need. So again, I'll put the origin in. So let's try it. 0 for x, 0 for y, greater than or equal to 2. No, that's wrong. 0 is actually less than 2. So I don't want that bit where the origin is. Let me cross that bit out. Okay, so that leaves one inequality left. This one, y is greater than or equal to 0. Well, y equals 0 is the x-axis, and if y is greater than 0, I want the top half. So let me cross out the bottom half. So I'm left with that triangle in the middle. Well, now that I've figured out what it is, I'm going to draw a new picture so that when whoever reads this sees it, it will be a lot less confusing. So I had a y-axis and an x-axis. I had this line and I had this line. And the set I wanted was here. Like that. So let me label the points on the axis. That's 3, that's 2, that's 1, that's 3. Now it's much clearer, isn't it? Okay, all I need to do now is find the vertices, which is what the question said. Now, a vertex, well, in English it means it's a corner. There's a proper formal definition, but corner will do for my picture. My set has 3 corners. It's got one here, it's got one here, and it's got one here. So the 2 that are on the x-axis there should be easier to write down. Vertices. I have 1, 0 and 3, 0. That just leaves this vertex just here. Well, that would be where the 2 lines that pass through that vertex meet. So I just need to figure out where those 2 lines meet. And those 2 lines were x plus y is equal to 3 and y plus 2x is equal to 2. So if I solve those 2 equations, that will tell me what that point is. So let's see. Well, if I subtract the top equation from the bottom equation, that will give me y plus 2x minus x minus y, so the y's will disappear and I'll just be left with x. So subtract, let me give them numbers. 2 minus 1, and that gives me x is equal to minus 1, and then I sub that back into one of the equations. So let's sub it back into equation 1, and I get minus 1 plus y is equal to 3. So I'm running out of space, so I'll just move my vertices down. Y is equal to 4. So my vertex is negative 1, 4 in terms of its coordinates. So therefore the vertices are 1, 0, 3, 0, and minus 1, 4. On to part B. So this time I have the set of x, y, and R2 such that x plus y is greater than or equal to 3, y plus 2x is greater than or equal to 2, and y is greater than or equal to 0. That's very similar to part A. Let me look back and see what part A looked like. Oh, with part A, it was a less than or equal to 3. And with this one, it's a greater than or equal to 3. But everything else is the same. So the lines will be the same, but I'll need to cross out a different part. Let me draw all the right pictures again. So here's a y-axis, and here's an x-axis. Now the x plus y is greater than or equal to 3. Let's do that part. The line x plus y is equal to 3, if we remember from part A, was this. And let's just check again which side we need, because this time we need greater than or equal to 3. So the origin, 0, 0, 0 plus 0 is greater than or equal to 3. Well, that's not true. It's less than 3. So we don't want the origin in our set. So let's cross out that side, cross out the bit we don't want. Like that. Okay, now for the next bit. Y plus 2x is greater than or equal to 2. So y plus 2x is equal to 2 was this line here. And greater than or equal to 2, as I recall, was the top half. We needed to cross out the bottom half of that line. But just let me check again. 0 plus 0 is greater than or equal to 2. That's wrong. So we need to cross out the bottom half of this line. Most of that's already crossed out, as you can see. Okay, now for the last bit. Y is greater than or equal to 0. So we'll cross out the bit where y is negative, which is this bit here. And we're left with this big white bit up the top. So just like last time, let me draw a new picture so that whoever's reading it, it'll be a little more obvious what's going on. So my set looks like this. And I wanted the bit above in that top corner. So we want this bit. That's my set. It looks like it's going to go on forever. Okay, it goes upwards forever in that direction. Doesn't mean it's not convex, just means it's not bounded. So the next step would be to find the vertices. So let's have a look. Where are the corners of this set? Well, there's one here, and there's one here. So we already found those vertices before. Vertices are minus 1, 4 and 3, 0. So that's part B done. We've drawn the set and we've found the vertices. Now we just need part C. So C, the set of x, y and R2 such that x plus y is greater than or equal to 3, y plus 2x is greater than or equal to 2, and y is less than or equal to 0. This one looks really similar again, so let's go back and have a look at the other one. x plus y is greater than or equal to 3, y plus 2x is greater than or equal to 2, and y is greater than or equal to 0. The one we want is the same, except it's y is less than or equal to 0. Alright, so the same lines are going to be the ones we want, so let me draw those lines in and then we'll decide which sides we want. So here's my y-axis, here's my x-axis, there's my 1, 2, 3, 1, 2, 3. We had this line. Now let's see, which side of that do we need? X plus y is greater than or equal to 3. We put the origin and we get 0 is greater than or equal to 3, which is not true, so we don't want the bottom side. So let's cross that out. And the next line was y plus 2x is greater than or equal to 2, which was this line. Like that. And we want it to be greater than 2, so we don't want the bit underneath. So I'll cross out that bit. Okay. And the last one is y is less than or equal to 0. So we want the bit where y is negative. So we'll cross out the bit above the x-axis. And we're left with just that bit in the corner down the bottom. So again, I'll draw a prettier set so that my reader can understand it better. So y, x, 1, 2, 3, 1, 2, 3. We had this line, we had this line, and the bit we wanted was this bit down here. Still unbounded, but this time only one vertex. So the vertex is 3, 0. The next part. The set of x, y in R2 such that x plus y is less than or equal to 3. 2 is less than or equal to y plus 2x, which is less than or equal to 4. And y is greater than or equal to 0. We've still got 3 inequalities, but the middle one here is technically 2 inequalities. There's one here, 2 is less than y plus 2x. And there's one here, y plus 2x is less than or equal to 4. So technically there's 4 things to do, and there's going to be 4 lines on my picture. If you look carefully, 3 of the lines are the same as the lines I've already done, so that should cut my work down. But either way, we still need to draw our axes. So there's my y-axis, there's my x-axis. And let's do the first line. X plus y is less than or equal to 3. That's this line again. So we want x plus y to be less than or equal to 3, so let's check the origin. 0 plus 0 is less than or equal to 3, so we want the bit below that line, so we'll cross out the bit above the line. Okay, the next one is this inequality. 2 is less than or equal to y plus 2x. Well, still if it was an equal sign, it would be a line. It would be y plus 2x is equal to 2. So, we've already drawn that line before. It's this line here. And we just want it to be 2 is less than or equal to that. So if we put 0, 0 in again, we'll get 2 is less than or equal to 0 plus 0, which is actually wrong. So 0, 0 isn't part of this particular condition. So we don't want the bit below that line. So let's cross that out. Alright, now let's do the next one. there's the next one there. Y plus 2x is less than or equal to 4. Well, we're going to have to draw that line because it's a new line. Y plus 2x is equal to 4. Well, let's see. If y is equal to 0, we get 2x is equal to 4, so x must be equal to 2. So that's just here. And let's put the y back into our equation. If x is equal to 0, then we'll get y is equal to 4, which is just here. So we need to join up those 2 points, like this. And it's supposed to be that those 2 lines are parallel, I reckon, because they have the same equation other than the number. So I think they're supposed to be parallel. Okay, so which side of that line do we need? It's supposed to be less than or equal to 4. Well, if we put the origin in, we'll get 0 plus 0 is less than or equal to 4, which is true. So the origin is part of the bit I want, so the bit I don't want, it must be the bit above the line, so I'll cross that out. Right, one left to do, and that's y is greater than or equal to 0. So that's the top half, so I'll cross out the bottom half. And I'm left with a quadrilateral in the middle there. So let me redraw my diagram. So it looks prettier, not so much cross-hatching everywhere. So y-axis, x-axis, 1, 2, 3, 1, 2, 3, 4. We had this line. We had this line. We had this line. And the set we wanted was this set here. Okay. So now all we need to do is find the vertices. We've already found this one, and this one, and this one. So all we need to do now is find this one here. And that's where the lines x plus y equals 3 and y plus 2x is equal to 4 meet. So we want the intersection of x plus y equals 3 and y plus 2x is equal to 4. So those 2 equations, well, we should do what we did last time because they're roughly the same except the number. If we do equation 2 minus equation 1, we will get x is equal to 1. And if we sub that back into the first one, we'll get 1 plus y is equal to 3, so y is equal to 2. So that point there must be the point 1, 2. So therefore my vertices are 1, 2. We've got minus 1, 4. We've got 1, 0, and we have 3, 0. Well, one part left. Part E, the set of x, y in R2 such that 2 is less than or equal to y plus 2x, which is less than or equal to 4. So it looks like we've picked out just that middle part of the last one. Well, let's draw it. There's my y-axis. There's my x-axis. Now if I recall, those 2 lines were these 2 lines. This part was this line here. And if 2 is going to be less than or equal to y plus 2x, when we put 0, 0 in for x and y, would get 2 is less than or equal to 0, which is wrong. So 0 is not part of the set I want. So I'll cross out this bit. Okay, now let's do the other bit. Y plus 2x is less than or equal to 4. So that was this. I'll just adjust where that 4 is. Okay, so let's see. If 0 is going to be in that set, 0 plus 0 is less than or equal to 4. So the origin is part of the set I want, so I don't want the bit above the line. So the set I want is the part between those two lines. Again, as usual, I'll draw a pretty picture for my reader. So there's my two lines, and the set I want is everything between those two lines. So that set is unbounded, it goes on forever, and none of those lines meet, so there aren't actually any corners at all. So I would say this set actually has no vertices at all. No vertices. And that is the end of the question.